Late guys, for some reason my video did not save, so I had to re-record. But these are the notes for 3.5 angles of a polygon. A polygon, our definition here is if a figure is a polygon, then it is formed by coplanar segments such that each segment intersects exactly two other segments, one at each endpoint, and no two segments with a common endpoint are collinear. This is a very formal definition. In just kind of normal terms, think of a polygon as a closed shape with straight sides. So squares, octagons, things like that, those are polygons. Circles and ovals are not polygons because they do not have straight sides. We have some names of polygons here on the right. Many of them you should be familiar with. Some new ones might be that a 7-sided shape is a heptagon. An 8-sided shape, you should know that's an octagon. 9-sided is nonagon. 10-sided is decagon, and 12-sided is dodecagon. Anything that is not on this list, we would just refer to it as an n-gon, where n is the number of sides, so a 13-gon, a 20-gon, things like that. A convex polygon. So we have two different kinds of polygons, convex and concave. Convex is what we deal with in this class. If a polygon is convex, then no line containing a side of the polygon contains a point in the interior of the polygon. In other words, all your vertices are going to point out. Whereas in a concave polygon, like this star, some of your vertices will point inward. So we tend to deal with convex polygons. Diagonals. If a segment is a diagonal, then it is a segment joining two non-consecutive vertices. When we draw diagonals, we pick one vertex to draw from. It does not matter which one you pick, but just pick one, and then you are going to draw diagonals that connect to the other vertices that this vertex is not already connected to. So for example, you could go straight down, across, and then across again. You do not want your diagonals to crisscross, okay? So you just pick one vertex to go from. Regular polygons. If a polygon is regular, then it is both equilateral and equiangular. For example, an equilateral equiangular triangle would be a regular polygon because it has 3 congruent sides and 3 congruent angles. A square would also be an example of a regular polygon. So any polygon where all the sides and all the angles are congruent. The polygon interior angle sum theorem. We're actually going to figure out the formula for this theorem in this table below. It says the sum of the measures of the angles of a convex polygon with n sides is blank. Well, if you have a 4-sided shape, what we can actually do is figure out the number of triangles to help us find the sum. Now, to figure out the number of triangles, we're going to draw diagonals. So pick a vertex, and then you're going to draw diagonals from there. In this situation, if it's a 4-sided shape, you can only draw one diagonal. Now, what that does is it splits your shape into 2 triangles. We know each triangle is going to have an angle sum of 180. That was from last class. And if you have 2 of them, you could do 2 times 180, which will give you an interior angle sum of 360 for a 4-sided shape. If you're dealing with a 5-sided shape, pick a vertex, draw your diagonals, and now you have 1, 2, 3 triangles. So we could do 3 times 180, which is 540 for a 5-sided shape. And then for a 6-sided shape, pick a vertex, draw your diagonals. That splits our shape into 1, 2, 3, 4 triangles. So 4 times 180 will give us a sum of 720 for those interior angles. Now, if you take a look, each time you figure out the number of triangles, it is 2 less than the number of sides. So 4-sided shape has 2 triangles. 5-sided shape has 3 triangles. 6-sided shape has 4 triangles. And then you multiply it by 180. So as a generic formula that we can use for any polygon, what we're going to do is we're going to take the number of sides, which is n, minus 2, and then multiply that by 180. So that's n minus 2 times 180 for our formula. Couple side notes, if a polygon is regular, so that means equilateral and equiangular, then to find the measure of one interior angle, you divide the interior angle sum by the number of sides. So if it's equilateral, equiangular, right, everything is equal. All those angles are congruent. So to find just one, you would take your sum and divide it by how many angles or sides there are, and that would give you just one. In a formula format, this would look like n minus 2 times 180 divided by n. You take your sum divided by the number of sides. Another thing is that the measure of one interior angle and one exterior angle will be supplementary in this situation. So imagine you had an equilateral, equiangular triangle. All your interior angles are 60 degrees, and if you draw your auxiliary line off that, well, what that does is it creates a linear pair. So if the interior angle is 60, the exterior angle must be 120, which would mean they are supplementary, and that'll hold for every shape as long as it is regular. Then we have a rule for our exterior angles. Polygon exterior angle sum theorem says the sum of the measures of the exterior angles of any convex polygon, one angle at each vertex, is 360 degrees. That's for all of them. Something to note, though, that if the polygon is regular, all their interior angles are congruent, which means all their exterior angles will also be congruent. So to find the measure of just one exterior angle, you would do 360, which is your sum, divided by your number of sides, which is n. It doesn't want to let me write there, so I'll do it off to the side. 360 divided by n. Then we just have some examples. For each polygon, find the interior angle sum and the exterior angle sum. Interior angle sum means we need to use our n minus 2 times 180 formula. So n is 120 because it's a 102 because it's a 102gon. So 102 minus 2 times 180. That's going to give you 100 times 180, which is going to give you 18,000. So this is for your interior angles. Then for your exterior angles, well, their sum is always 360, no matter what shape it is. Then for a dodecagon, that's a 12-sided shape. So for your interior angles, you would do 12 minus 2 times 180, which is 10 times 180, which is 1800. And then for your exterior angles, that's again always 360. For number 2, it says complete the table for regular polygons. If I give you the number of sides, I want you to find the measure of each exterior angle and each interior angle. That means just one, and then we're going to work backwards from some of them as well. So if this is a regular polygon, then we know everything's going to be congruent. So the easiest way to find the measure of each exterior angle is to take your exterior angle sum, which is 360, and divide that by your number of sides, which is n. So if your number of sides is 6, 360 divided by 6 is 60. Then your interior and exterior are supplementary, so 180 minus 60 is 120. Then for 10, 360 divided by 10 is 36. And then for your interior angle, 180 minus 36 is 144. Then if you have 20 sides, 360 divided by 20 is 18. And for your interior angle, 180 minus 18 is 162. Now, if I give you the measure of an exterior angle, it's easy to think you need to work backwards and multiply by 360. However, if you have a sum of 360 and each one of those is 10, you can actually still just divide. So you can take 360 divided by each exterior angle. And if you did 360 divided by 10, that means that there are going to be 36 sides. Because think about if you did 360 divided by 36, that would give you 10. Then to find your interior angle, do 180 minus 10. That's going to give you 170. Then here you have an interior or an exterior angle. So do 360 divided by 20. That would give you 18. And your interior angle, do 180 minus 20. That'll give you 160. And then if you're given an interior angle, you can easily find the exterior by subtracting from 180. So for this one, you'd get 1. And then 360 divided by 1 is just 360. Then for 90, 180 minus 90 is just 90. And then 360 divided by 90 is 4. Next thing, we have an always, sometimes, or never. The sum of the measures of the exterior angles of any polygon is 360 degrees. That is always true. The sum of the measures of the angles of a convex polygon is 360. Now, when it just says the sum of the measures of the angles, it means the interior angles. That's going to be sometimes. It would work for a quadrilateral, but not for anything else. A segment joining two vertices of a polygon is a diagonal. That's sometimes. It could be a diagonal, or it could simply be a side of the shape. The sum of the measures of the exterior angles of a polygon depends on the number of sides. That's never. The sum is always 360, no matter the shape. A regular polygon is equilateral. That is always. Regular polygons, by definition, are equilateral and equiangular. And then for part F, an equiangular polygon is regular. That's going to be sometimes. Because think of a rectangle. A rectangle is equiangular. All the angles are 90, but it is not equilateral. So that doesn't mean it's not regular. So in number 4, we had some typos here that we need to fix. This should say the sum of the measures of the interior angles of a regular polygon is 5 times that of the exterior angles. Sorry about that. How many sides does the polygon have? So the sum of the measures of the sum of the measures of interior angles of a regular polygon is 9 times the exterior angle. So this is saying the sum of the interior angles is 9 times the sum of the exterior angles. How many sides does this shape have? So we do have a formula for the sum of the interior angles, and that's n minus 2 times 180. Because it says the sum of the interior angles is means equals, and then 9 times that of the exterior angles. So that's implying the sum. So we would do 9 times the sum of the exteriors, which is 360. Then we can simplify. I'm going to distribute the 180. There's a few different ways you could simplify this, but I'm going to distribute the 180. So I'm going to get 180n minus 360 equals, and then multiply your 9, 3,240. I'm going to add over my 360. So that's 180n equals 3,600. And then I'm going to divide that to get that n is 20. So this is a 20-sided figure. Then for number 5, thankfully no typos here. It says the measure of each interior angle of a regular polygon is 15 times that of an exterior angle. So each interior angle is 15 times the exterior. Well, if you go back up to the front, If we wanted to find just one interior angle, we would take our sum divided by the number of sides. So what you're going to do here is each angle means just 1. So to find the measure of 1, you would do n minus 2 times 180 divided by n means equals 15 times of an exterior angle. So again, if you go back, an exterior angle is 360 divided by n. So we would do 15 times 360 divided by n. There's a few different ways to then solve this from here. I'm going to just rewrite the left, n minus 2 times 180 over n equals, I'm going to divide my 15 over here and get 5,400 over n. Then, since they're both divided by n, I can actually cancel that out so I don't have to deal with that anymore. And I'll have n minus 2 times 180 equals 5,040. Now, you could distribute your 180 if you want to. I'd rather work with some smaller numbers, so since I'm multiplying by 180, I can divide both sides by 180. That'll just leave me with n minus 2 on the left, and 5,400 divided by 180 is 30. Then add your 2, and this would be a 32-sided shape. Let me know if you guys have any questions, and don't forget to submit things to the requested homework solutions. Have a great weekend.